you're leaving.
Yeah, I'm leaving now.
It's ready to come back over here.
Yeah.
Great.
Hopefully things will be settled down there. So, yeah. More stuff every day.
Yeah. And in Washington too.
Yeah.
It's an exciting time to be a journalist. I don't know.
Randy is in Puerto Rico,
Oh.
so Ahmed's going to meet with him next week.
Oh, he's not in Skype.
No, he's going to meet with him next week.
So Tuesday.
Yeah, that's what Randy wanted to give me, so that's fine. So I think we're all here. So if you, whenever you're ready.
Yeah.
No, I didn't print out the slides. Do you want? I can print some out real quick.
I can print them.
I got paper.
If you want, he can send me the printer and I can get them on the slides.
Yeah, I won't be the only one.
No, that'd be great.
Okay, can you send me the printer, send a couple copies?
Yeah.
And I'll run down there and maybe send.
Yeah, let me send it from.
Okay, because I don't know if I have your final set.
I just leave them in the car.
And I'm not sure if I can print from this machine. So you can't read for more than an hour or two and take a break?
Yeah.
Is that permanent or is that just?
No.
So we're just seconds, right?
Late.
Yeah, I know. Yeah, it's really fun.
This is like still in December.
Oh.
And you can feel the burning. Walking in the back of your eye.
Yeah, I'm like, okay, I gotta keep laying here. Just let them run out. I'm like, brilliant. So did they, I guess, didn't really check out, have any pictures of me. Correct.
Well, I still have a floater. I can't do it.
Oh, okay.
I can try.
Yeah, no, I know.
Jelly thing like
I know, I have, I'm getting that, it's just, they can do something. Oh, really? I just live.
I had both my eyes drained and the sight, yeah, and then put the back, but, yeah. And I can see, well, they also, I had detached retinas, and I had corneas, and I've had about 5 operations in both eyes, so. And I'm going to a physician to do everything tomorrow, or tomorrow, this afternoon, but, that was the best thing I've ever done, was get them running. They Helen Keller clinic, that's it. And, about 2 years. And that's why, but my eyes are always red now. And they do it one at a time, I do still, so it's
Of course, double the phone. At the same time, and why would they?
I think they cataract that way.
I know, one at a time.
Yeah.
Now, why don't you go ahead and start, because I've heard it, so. I'll go walk down there and get him just a second. It'll take him a second.
Yeah. I sent 4 slides per page.
Okay, I'll walk down there in just a second and get him.
And I was 240, 250 before this.
Wow.
Where'd you go?
Yeah, it's the clinics at UAB, which is great, and they all have specializations. So,
Okay.
so the Helen Keller Clinic does all the internals to the eyes. Primary, Matt Michelson does the cornea stuff.
I'm gonna let him go ahead and start, because I've seen it, so I'll walk down and get the slides, and that way we can go ahead and start, so I'll be right back. First 1 or 2 videos.
Good morning, everyone. Thank you very much for coming and for the defense. So, at the beginning of every research idea, or whenever we want to start new research, we try to look at what's out there, what has been done, try to figure out, like if we're trying to resolve a problem, we try to understand what's have been done and what's needed. So we try to look in the literature and we try to find out this information. Or sometimes we want to start a new research and we don't have an idea about it, so we look in the literature and we try to understand this, this research idea that we want to work. So whenever we want to start writing a paper or research, we do this process and we call it literature review. However, this process have some problems. For example, when we look in the internet and we find some literature, we usually take the literature that sometimes it's in our favor and that could be biased. And because we don't search everything, we might miss on some information. Sometimes it's also difficult for other people to repeat our research because they don't know which or how we did our search for the problem to find the information about the problem. So to overcome these problems, it was introduced in the medicine a new approach for literature review. It's called systematic literature review. It came from evidence-based medicine and it started, I think, back 30 years, 40 years ago. And it has been very successful in the medicine. And because of its success, it was introduced in the software engineering around 2004. And ever since introduction, there were at least 370 published SLRs in software engineering. So it has been an increase. The adoption for this methodology has been increased since 2004. So what is the SLR process? So it's just it's a process that is formal, repeatable, produce results that have higher quality and reduces bias. And it does that by the process have three main stages: the planning stage, an execution stage, and a documentation stage. And these stages that ensures that your results will have higher quality and it will ensure that you have less bias in the results. So, and to look into more details inside each stage, so for the planning one, we usually have the motivation, why we want to do this research, the protocol, we define the research questions, we define where we're going to search, what we're going to search, we define the forms, the data extraction forms that we're going to fill. In the execution phase, we take the plan that we have, or we execute it. We look for literature, we search, we select the literature that we will include in the study, we'll do quality assessment, we'll get the information and data extraction and synthesis, and finally we'll write up the SLR document in the documentation phase. In my dissertation, I'm focusing on the searching phase. The searching phase also consists of multiple things inside of it. So we need to search for literature, we need to obtain this literature, the storage of it, and the collaboration that happens when, because in the SLR process, multiple researchers work on it, and that's what also ensure reducing the bias in the process. So even though the SLR process have been very famous in the software engineering for the past years, it still suffer from a lot of barriers. And these barriers goes across all the stages. Barriers in the protocol, in the planning, and searching, barriers in data extraction and documentation. The barriers I'm focusing on in this dissertation are the barriers that are related to the search phase. So in the search phase, we have barriers related to digital libraries, barriers related to researchers themselves, and the missing tool support as well. So the main goal of this dissertation are three. So the first research objective is to identify empirical evidence that confirms there is the existing of the problem in the searching phase. I also wanted to confirm the current status of the current tool supports. The second objective is to understand the barriers and tool requirements for the SLR search phase. And eventually that leads to the third research objective, which is build and evaluate a solution to reduce those barriers. So my plan to solve those research objectives were, first, I conducted 3 articles. The first article is a combination of 3 other articles that study the SLR process in general. From that, I produced a list of requirements across all the SLR stages, and it motivated, and because of a lot of barriers and problems happens in the search phase, it motivated the second article, which was consisted of two studies. First, an SLR to find out all the requirements and the barriers in the literature, and the second one is a survey that we sent to SLR researchers to also collect requirements and to understand the barriers and the requirements in the SLR search phase. From that, we produced another list of requirements that is functional requirements specific to the SLR search phase only. And that motivated the third article, which was designing and building a tool to solve those requirements and evaluate the tool, evaluate the usefulness of the tool. And the status of those articles are now all complete. Okay. So the main contributions of these dissertations is first to provide empirical evidence on the issue of the SLR search phase. And the second one is to provide requirements, functional requirements, and these functional requirements can be a reference for SLR authors, researchers, and tool developers. Whenever they want to work on something to reduce the barriers in the SLR search phase, they can get back to this requirements. And hopefully, because we enhance the tool support, that enables SLR researchers to conduct SLRs faster and more efficient. And because it's more systematic and using tools, hopefully that increases the quality of SLR in software engineering. So now I'm going to go through the articles, the 3 articles. So the first one, like I said, it was a combination of 3 articles that all of them were talking about the barriers and the SLR process in general. And so it has 3 data sources. The first data source was a survey study that was conducted specifically to understand the SLR barriers in general, and especially the novice ones, especially the ones that is faced by novice researchers. It had 50 SLR researchers and 8 PhD students who took a course about SLR research and conducted SLR research in the course. So from the results of this study, the participants have identified which stages in the SLR process are the most difficult, the most time-consuming, and the most in need for tool support. And from the first study, you can see that the database searching was the 3rd highest in time-consuming, and it was the highest stage in need for tool support. The second data source that was in this study, it was a workshop that conducted at the ESAM conference, and in this workshop, the goal was to identify SLR barriers with the SLR community. So participants were 11 SLR researchers and 2 PhD students. 10 of those SLR researchers were from computer science field, and 1 of them was from the medical field, and he was invited to ensure that the process is valid and correct. The results of this study produced 100 requirements, 100 individual requirements. They were grouped by the researchers at the workshop, and they were prioritized, voted on. And based on their voting, these were the top 10 requirements. And also from the top 10 requirements, or the top 10 barriers. So from the top 10 barriers, you can see that the highest one was also lack of tool support for the SLR process. And also things that is related to the searching phase. The third data source that was in this study is another workshop that was conducted at the EAST conference. And the goal of this workshop was to identify requirements across the SLR phase. And the participants were 16 SLR researchers. 10 of them were experts, 6 of them were novice. And they were classified based on if you conducted 3 or more SLRs, you're an expert. Lower than that, it was considered to be novice. The results of this study produced 99 or 98 requirements, and they were grouped also in 28 composites, and they were voted on by the participants. And the top 10 were also, the top 10 requirements across all the stages were also, you can see that the integrated search was the highest, and these 2 were equal, so that's why there are 11 over here. Okay. So in this study, I took the results from the survey, I mapped it back to I took the results from the workshop, from the various workshop, mapped it back to the survey, and ensure that all the barriers that we found in the first workshop, actually showed up in the survey. And then I mapped this other workshop back to the first one, and I was making sure that the requirements that showed up in the workshop also showed up as barriers in the previous workshop. This mapping was important because the participants in each of these studies were different, and that's why if all the requirements cover the barriers and the barriers also got covered, that means all the people are facing the same problems, and all of them they have the need for the same requirements. From the mapping of these three, I produced a document with 112 requirements that goes across all the stages of the SLR process. Now, I took this 112 requirement and I did tool analysis, feature analysis. So I went and looked in the literature. We found out that what are the tools that have been used in the SLR phase, and did a feature analysis across all the requirements that we had. So from this analysis, so inside each one of these are composites. So inside each one of these, it has multiple requirements. And if this requirement is satisfied by the tool, that means it's fully covered or not fully covered, and that's how the score were calculated. So you can see that from all this, that none of the tool actually cover all the requirements, and none of the requirements can be covered by, even if we use all the tools. Also, important thing to see here is number 2, the integrated search. That a lot of these tools do not they don't have a lot of support for integrated search and for the search phase in general. So from this study, we can see that the requirements are everywhere. They're in all the stages. And there are a lot of gaps in the tools. The current tools are still not supporting all the requirements. And it's very difficult to have integration between these tools. So if you use a tool and you do some part of it, you might be locked in and you cannot go to use a different tool. And this also was another, like one of the issues, reuse and evolution, because SLR is supposed to be a living document, and a lot of people might face the same problem or do similar research, and you already use the data, but it's difficult to reuse the same data and these kind of stuff. So this was a problem as well. Also from the requirement, collaboration was needed, and a lot of people talked about it across all the stages of the SLR. However, we saw that the newer tools were doing actually better than the previous ones, and that people or the tool developers are working better with the community to address those issues. So because of a lot of issues were related to the search phase, and we found a lot of issues in the search phase, and we also found that the tool support is not supporting the search phase. That was the motivation for the second article, which was identifying functional requirements specific only for the SLR search phase. So in this study, it consisted of 2 parts. First, an SLR to find the problems in the literature, and second is a survey with the SLR researchers. So for the SLR part, I searched the digital repositories, IEEE, ACM, Scopus, Science Direct, and conducted an SLR looking for 2 things. First, I was looking for anything that is related to systematic reviews in software engineering and have problems with searching, or have tools that support the SLR process. And because in tools, that could be somebody talking about SLR, about searching issues and saying there is an issue and we need to solve it or something. So from that, I found about 1,300 papers, cleaned them up from duplicates. There were 800. After that, there were 200 left to fully reviewed. And from those 200, there were 86 papers that were included in the final study. So for the results from the part of from the SLR, I found 29 problems in the literature that have been reported. 55% of them had no solution. People did not report solution or did not even say anything about those problems. They just said, we faced this problem. And the ones that had solution, they had semi-systematic solution. So what I mean by this is, for example, if I have a search query and I go to ACM and I search this search query, and then I go to Scopus and I search the exact same search query and it doesn't work, people were either removing a word from the search query or rearranging or something, and that leads not a systematic process, which defeats the purpose of SLR. So that's what we call semi-systematic solutions. And because we have these semi-systematic solutions and we have a lot of problems, that was affecting the quality of the SLR and make it more difficult to be repeatable. Also, because we found a lot of problems in the literature, that also confirmed that the SLR searching phase is still an issue, and there weren't enough studies about them. So all those problems came from people who were conducting SLR, and they said, "Oh, we faced this problem," as they were talking about their SLR. It wasn't a specific study. And we did not find tool support reported in the literature, but all these 29 problems could be solved by tool, because they're, like for example, the search terrain can be converted. We can have a tool that converts it to multiple formats. So we have these problems from the literature, but it was still important to see if these problems are still valid, or if there are more problems to cover, or something got solved, or maybe more tools that can be used. And that's why we conducted the survey. So we conducted a survey where we sent it to people who published SLRs, and we sent it to 600 researchers. After removing bouncing emails, there were 550, and about 200 answered the survey. 130 researchers were considered for the final results. So the way we designed the survey had 4 aspects. The first one is we wanted to know what is the experience of those researchers. We wanted to know how many SLRs they have been working on, they published, and if they're currently working on SLRs or not. And we wanted to understand what problems do they face in the SLR search phase, and what solutions they use to solve those problems, and how do they evaluate their solutions. And also we asked them about what tools did they use in the SLR search phase only. And about those tools, we also asked what are the advantages and disadvantages of these tools. Of course, the survey was first pilot tested, and we tested out with software engineering researchers, and it was also reviewed by people who are experts in SLRs and people who are experts in surveys. We sent out the survey. Electronically, and then we followed up after 2 weeks to remind them to answer the survey. And after a month, we closed it off once the responses were done. Then when we collected the data were analyzed by 2 researchers. So we took part of the data, we coded it, the other researcher coded it. We were checking if we both agreed, and we take another batch until we finished all the data. So all the results were analyzed by 2 researchers. So the results of the survey, it showed 192 problems in the SLR search phase. And we grouped them into 29 problems, so some of them are duplicated. And we found 154 search strategies that were grouped in 15, and these were the questions that we asked them: what is your best strategy to search? When you search, what do you do? So a lot of people said just a snowballing, or said we use only Google Scholar. So that was the search strategy. And we found 176 requirements that were for the SLR search phase. And what's interesting is even the people that said there are no problems, they don't face problems in the SLR search phase, they still gave requirements and need for better tool support. We found the 24 tools that reported in the search phase, and only 4 of them there were specific SLR tools. The rest were either Excel, Google Docs, Google Drive, spreadsheets, these kind of tools. When we matched the problems back from the researchers' results back to the SLR results, all of the problems matched back, and the top 10 showed up both in their survey and showed up both in the literature. And so the problems still exist, but Again, they're all solvable, because if we can classify them, we can see that some problems related to digital libraries, where we just need better communication with digital libraries providers, and hopefully we can work on something there. Some problems related to automation, so for example, the search string, the conversion of the search string, this could be automated, the download, the storage. And some problems related to the SLR researchers themselves. So some people said we did not know how to search or which database to choose. So these problems are solvable by just going back to the guidelines and the book for the systematic literature review. So just maybe just better guidelines or more guidelines to the researchers. From the solutions that were reported, there were also semi-systematic solutions. So it's the same thing that we found in the literature. And we also found the tool support is still needed. So from this, this motivated the third article, which was building a tool to solve those problems. The tool that we built is based on Article 1 requirements and Article 2 requirements. It took all the requirements in consideration from the SLR, the survey, and the workshops. So the tool that I worked on is consists of multiple components, and it has a query converter, database search, citations download, and I'll go in details in each one of these. So the first one, it was a query converter. So taking the requirements from community workshops, surveys, SLRs, the highest one was searching multiple databases and standardized the query. So we took that and limitation on search string. So I took that requirements and I built them into a module that solved this problem. That takes one query, you just hit convert, and it converts it to multiple databases. Currently it supports 5 or 6 databases, but I can add more as in the future. The second feature we had in the tool is the ability to search multiple databases, and also these were the requirements that were considered. They were also coming from community workshop, the SLR, the survey, and this one is searching just the digital libraries in general, and put your query, select your digital library, or all of them together as searches. And it brings the result the same one as it shows up in the digital library. So it's not missing anything, any of the results that is at ACM or IEEE. Third component was citation download, and it was also very high. That everywhere we see it in community SLRs and surveys, a lot of people were saying it's difficult to download papers, especially from ACM. So we created a module that works on downloading papers, and it works in 2 ways. You can either just put your query, select the database, you search, so just the same search result that we see, and you download, or you can just simply just paste the URL that you were working on, and it starts downloading the results. The fourth part is the storage, the backend storage. So for the backend storage, we considered these requirements, and it was working on either remote or local databases. The reason I was using databases and not just storing BibTeX files, because I wanted to conduct more operations on this BibTeX, like removing duplicates, which was also very important. And the other parts, I wanted to enable collaboration, so that's why it was important to have a database that sits in the back and use this database to conduct a lot of those operations. The other component was citation management, so downloading those citations, it would be very useful to use them and not just to have them in the back end, and that's why we created a citation management where you can see where you download it, you filter, and just a simple management tool. One of the highest requirements was archiving, and for archiving we created a module that tracks the entire process, what you're doing, and it checks what you searched, what you converted, when did you download it, and also it reminds you, if you search for a query, it reminds you again that this query had newer results if you want to look at it or something. The other part of it, it was very important because we saw that integration is difficult through all the tools. So we created an import and export feature that enables researchers to work with, that enables the researchers to use this tool export the results and use it with a different tool, or import results from outside and use the tool to remove duplicates, for example. So when I was doing the dissertation, my reference file had a lot of duplicates, so I just put it in the tool and exported it again, and that's it. Yeah. So the second, the more important part about this paper is the evaluation of this tool. So I conducted 3 informal in-house evaluations. We conducted feature analysis, replicating an SLR, and external users. So the reasons behind each one of these evaluations, the feature analysis, because it would be just objective. It would be, it's either solve this feature or it doesn't solve this feature, and that's it. So no bias in the feature analysis. Replicating an SLR because I wanted to see how the tool work, and because I already done an SLR, so I would compare the results with the manual one. And for replicating an SLR, I took the same SLR that I showed you earlier in the second article and redid it using the tool. And the third one is external users, because these are done by the developers of the tool, but this one would be from a different perspective, so they might have different issues or suggestions on the tool. So for the feature analysis, when I conducted it, I also compared the results to the rest of the tools. So you can see that currently the tool that we designed solve more requirements than the rest of the tools, but that is expected because the results of this study have not been published, so the other tools did not see those requirements yet. Now, the score for the rest of the tools are based on their support for the SLR search phase alone. So, for example, START scores way much higher, but in a different stages. For example, visualization, or maybe in the planning of the protocol. But this evaluation was specific only to the SLR search phase. So yes, so we see that the tool that we designed, SSRT, is higher, but still half of requirements are still not covered. But what I wanted to do is just focus on the high priority ones and focus just to make sure that it's feasible to conduct the highest priority ones to actually implement them. But there are more requirements to be covered later. For replicating SLRs, the results were, I was looking at the time, the ease of use, the coverage, and the duplicate. So for the time, it was way much easier to just get the results done in a few hours versus doing it in a few days. The ease of use, it was requiring just a few steps, just put query, hit search, and download, and that's it. The coverage was exactly the same, because in the coverage, the tool get the results from the digital library, so it would be the same thing if you go search them. But because the tool produces more, for ACM, for example, if you change the query location, it produces different results. So the tool gives you this option that to have the multiple queries. So when you search that, you might get more papers. But if you take all those queries and put them in ACM, you'll get that same coverage again. Finally, duplicates were reduced in the results, but they weren't 100% eliminated. And that's because the rules I applied in the tool, it was only based on the author, the year, and the title. So I did not consider other stuff that removes duplicate. But the reason I chose those 3 is because it's better to have papers duplicated over missing important paper that got removed by mistake. I also found small backend issues that needs to be resolved. So for example, exporting BibTeX, sometimes it was changing the key for the BibTeX, so I can solve that later. For the external users evaluation, we had a PhD student test out the tool, and we had a team in Italy. They were conducting an SLR. They also tested out the tool. Both of them weren't formal evaluation, just informal, in fact, based on their feedback. So they said the users that used the tool, they spent less time using it on the SLR search phase. They had fewer duplicates, and it definitely reduced the manual efforts. They asked to add more digital libraries because currently the tool supports only 3, but they asked to add more, so that means it was useful. And but also still have some issues. For example, I'm running multi-threaded features in the background for download and search, and sometimes you don't see the progress for all of them, so they suggested better user interfaces in some places. So once again, the contribution for all the dissertation is first providing empirical evidence, and that was done using Article 1 and Article 2 that there are problems in the SLR search phase. We provide a list of requirements specific for the SLR search phase and for the SLR process, and hopefully these requirements can be a reference for SLR authors, developers, and researchers to use whenever they want to go back and look at the SLR process, the SLR search phase, and they want to reduce the barriers there. We developed a tool, and hopefully using the tool, this enable people to conduct SLRs faster and more efficient, and reducing the semi-systematic solutions hopefully increases the quality of SLR in general as well. So my plan for the publications for this dissertation, the first article, it's a journal article, and we submitted it to the Information and Software Technology back in December. We're still under review. The second article, it consisted of 2 studies. So the first one was submitted to the ESAM conference about a month ago, 2 months ago. It was the survey part, combining the survey and the SLR together, and we'll submit it as a journal paper for the Information and Software Technology. And finally, the tool article and its evaluation, and I will add a little bit more evaluation maybe in the future, and we submit it to the Information Software Technology as well. Now, my plan for future research. So I have three main parts I would like to focus on. But so first is the SLRs in software engineering. In this dissertation, I was focusing only on the search phase, and I was tackling the issues here. But all these phases still have a lot of issues. So it'd be interesting to work on these stages, also collect requirements, build up tools, and enable all those tools to work together to build one framework to support the SLR in software engineering as a whole in the entire process. My other interest is software engineering and industry. So we do a lot of research here in software engineering, but still there is a gap between the research part and the industry part. So I would like to focus on that and try to understand these gaps. I will not be able to remove this gap, but hopefully get it a little bit closer and make the research also benefit the industry as well, and the industry can have more problems that can be solved by research. And the last part is user experience research. So every application we conduct here, everything we build, is used by the user. So if the user doesn't like it, then it doesn't like it. No matter how good the project is, how good the software is, it can be a failure. So it would be interesting to work on user experience research and work on how we study those users and how we enhance this this field, the UX research. Finally, I want to thank Dr. Cover. 4 years, you taught me a lot, Doctor. And I want to thank my community members, Dr. Hill, thank you very much for working on a lot of papers together. Dr. Gray, thank you for a lot of feedback, a lot of useful feedback in meetings. And Dr. Babaski, of course, a lot of classes and database classes. And Dr. Randy Smith as well. He provided a lot of feedback in the proposal. And I would like to thank the software engineering group students. They provided amazing feedback throughout all the presentations for the past 4 years. Here's also a list of publications that were done in the past 4 years. And there are the planned ones are not here as well. So, thank you.
I guess, are there any questions from the audience?
Can I ask a question? So,